this is the rest of 4.1 lesson. So we were on example 2, and you should already have this done. I'm just going to do a quick review on how to find all these things. So don't forget that the standard form for a quadratic equation is ax squared plus bx plus c. And so let's identify a, b, and c for this function. So there's a 1 here. That's our a value equals 1. So if there's nothing there, you put it's 1. Or if it's a negative, you put -1. And then b is equal to a -4, and then c is equal to 2. So you just have it in standard form and line them up. A is the coefficient of the quadratic term, b is the coefficient of the linear term, and c is your constant term. So there were 2 ways we found the y-intercept. The y-intercept is when x equals 0. So if you plug in 0 for x into the equation, you will get 2 because these two zero out. And it's always known that if it's in standard form, c is going to be the y-intercept, because that will happen when you plug in 0 for x. It'll always zero out these two terms. So for that one, our y-intercept is 2. And then to find the axis of symmetry and the x-coordinate of the vertex, those are the same exact thing, and we have a formula for that. So that's your negative b over 2a. So we're just going to plug in negative of our b, which is a negative number, so that's going to turn positive. So negative of -4 over 2 times our a, so 2 times our 1. And so you get +4 over +2, so your x-coordinate of the vertex is 2, and that is also your axis of symmetry. And then we made a table of values using the vertex. So instead of just doing -3 to 3, we found the center of our graph, which is our vertex. So we'll make that our center instead of the origin. So we're going to do -1, 0, 1, 2, and then 2, 3, 4, 5. 3 above and 3 below. And remember, if the points don't fit on the mini graph, as long as they're not important points, that's okay. And remember, we're just plugging these, we're finding points on the graph, so you plug these in for x into your equation to find their output, or the y values. So plug in those x values in our table here. So these are some of the values you would have gotten. And remember, notice the symmetry about the vertex. I'm just going to show you how to find the rest of the vertex. So this is the x value of the vertex. So to find the y value, you have to plug in the x value to the equation and find its output. So all we're doing is plugging in 2 for x. So don't forget to use parentheses. 2 squared minus 4 times 2 plus 2. So you get 4, and then minus 8 plus 2. 4 minus 8 is -4, and -4 plus 2 is -2. And so that's your vertex, is 2, -2. And now we can graph it. So just graph those points. So you have 2, -2 is your vertex. And then we can just graph the rest of the points. And then once you have the points graphed, just connect the lines with a smooth curve with arrows, because it goes on forever. And then that's your graph. We do want to identify the key points of the graph. So the key points are the vertex, which we already know is 2, -2, the y-intercept, which we already know is 2, and then the x-intercepts. So remember, the x-intercepts are where it crosses the x-axis. So here, we don't have exact values for this answer. So we're just going to say what 2 numbers it's in between. So this x-intercept right here is between 0 and 1. And then we have a second x-intercept, and this one right here is between 3 and 4. And we don't say 1/2 and 3 1/2 because we're not sure if it's exactly in the middle of those 2 values. And it's probably not. And then, so we can use the graph to figure out those x-intercepts, but you can also use the table. So in the table, we can see that the y-intercept is 2 because that's when x equals 0. So you look at the x side of the table and look for 0, and then your y is your output, and so that's your y-intercept. So for an x-intercept, we're looking for the y value to be 0. So if you look in this table, there's no zeros for y. So that doesn't mean that we don't have one necessarily. It means that there's not an exact integer value for x for for our x-intercept. So what we're looking for is a sign change, because if you look here, our output is 2 and then our output is -1. This is a continuous graph, so you don't pick up your pencil. So if you're at an output of 2 and then all of a sudden your output is -1, you had to have hit 0 somewhere in between there. So that's why you're going to look for a sign change in the y side of the table if there's no zeros. And there could be one nice 0 and then another one that's just a sign change. So here, since there's a sign change between 2 and -1, our x-intercept's between 0 and 1, and then we have another sign change from -1 back to +2, which means our other x-intercept is between 3 and 4. One thing we want to be sure to graph on these is the axis of symmetry, and that's your dashed line down the middle. And that helps you find twin points too. Okay, now we have some notes. You need to pause the video and write this down, and then I'll talk about it some more. So the maximum value is the largest output on a graph, and the minimum value is the smallest output on a graph. And for a parabola, you will only have one or the other. You can't have both. And so when I ask for the maximum or minimum, I'm just talking about the y value. So the max and min always occur at the vertex. But when you're saying the max or min value, you don't give me a coordinate point, you just give the y value, unless I ask for the maximum point or minimum point. But you do need to know the x value of the vertex in order to find the y value of the vertex. So in our table, we have max or min, and that's for a quadratic equation, a not equal to 0, otherwise it's not a quadratic. So the orientation means just if it's opening up or down. So if it opens up, then a is greater than 0. And what these arrows mean is that one determines the other. So if you know it opens up, you should know that a is greater than 0, and a is that coefficient of the quadratic term. And then if a is 0, you should also know that it has a minimum. Or if you know it opens up, you should know it has a minimum. And then if you know it has a minimum, you should know a is 0 and it opens up. And so it looks like this if it opens up, and so that it has a lowest point, and so that would mean it has a minimum. And then it's exactly opposite for a maximum. If it opens down, a is less than 0, so it's a negative number, which means it has a maximum, and it looks like this because it has that highest point there. And again, if you're talking about the max or min of a parabola, minimum value or maximum value, it's just the y value. So make sure you have that written down. I'll check your notes on Wednesday. But you might want to write down that always occurs at the vertex. So if I ever tell you to find the maximum or minimum, you should know you need to find the vertex. Okay, for example 3, we're going to look at this function, negative x squared plus 2x plus 3. And I apologize for the audio quality. I had my microphone on the wrong side. So it should be a little better now. Okay. So the first part says determine whether the function has a maximum or minimum value. So we need to look at our equation, and what determines that is our a value. Since a is negative, that means it's going to open up, or open down, which means we're going to have a maximum value. So you will need to explain why it has a maximum or minimum value. So you can say, because a is less than 0. So a is equal to a negative number, it's going to be a maximum. Now we need to state that maximum or minimum value. So that means find the vertex. In order to find the vertex, we need that formula to find the x-coordinate of the vertex. So that's negative b over 2a. So for our function, a is equal to a negative 1, remember, because whatever in front of the x squared term, and then our b is equal to a positive 2. So we're just going to plug that into the formula. So we have negative b, so negative 2, over 2 times a, which is negative 1. So you get negative 2 over negative 2, which is a positive 1. So we know that the x value of our vertex is positive 1. And the max or min is the y value of the vertex. So we got to find that using the x value of the vertex. So you're simply going to plug that into your equation to find its output. So be careful here, you have to use parentheses. So right there is where you might get tripped up. So it's negative of the input squared, and our input is a positive 1. So only the positive 1 is being squared, not the negative. The negative is on the outside. So this will always be negative. If the negative is not there, it will always be positive. So negative of 1 squared plus 2 times 1 plus 3. So we square 1 first, so it's 1. So it's negative 1 plus 2 times 1, which is 2, plus 3. And then negative 1 plus 2 is 1, plus 3 is 4. So we just found the vertex. Our vertex is 1, 4. So what is the maximum value? It is 4. So you say maximum value 4. And that's your final answer for part B. Then we have part C, which we need to use the information we just found from part B. So we know that our vertex is 1, 4. So we're supposed to state the domain and range of the function. So remember that domain is the possible x values. So essentially, what can you plug into this function? What can you square, apply a negative to, and add to twice that number and add 3 to? And that's going to be any number. So for all quadratics, unless there's some restriction, which in general there's not, you're going to have all real numbers for your domain. So x contains a set of real numbers. For your range, we know that this graph opens upside down, and we just found out that that vertex is 1, 4, so our maximum value is 4. So that tells you your biggest output you can ever have. And then since it's opening down, anything less than that is also included because it goes on forever. So since this is your biggest value for your range, we have y is less than or equal to 4. So anytime you need to find your domain and range, for your range, you need to know the vertex because you need to know if it's the biggest value or the smallest value, and that helps you determine what your range is. So you cannot plug in any number into this equation that will give you an output of 5. There's no number that will give you an output of 5 or anything bigger than 4. Okay, the last example is a real-world problem, and it involves some thinking here. So a souvenir shop sells about 200 coffee mugs per month for $6 each. The shop owner estimates that for each 50-cent increase in price, he will sell 10 fewer coffee mugs per month. How much should the owner charge for each mug in order to maximize the monthly income in their sales? So the first step in doing these real-world problems is to create an equation. So write that down. Step 1, create an equation. And you need to ask yourself, what are you trying to maximize or minimize? And that's going to be your equation. So in this case, we are trying to maximize profit. So how would you find profit given the information? So we want to write this in words first, and that will help us get the equation. So to find profit for this situation, profit is equal to the number of mugs sold. I want you to write this down too. Number of mugs sold times the price per mug. You will have an example like this in your homework, not in the one you're going to do tonight, but in the next one. So now we need to actually get some numbers in there, and a variable. So we need to define our variable, and that's what's changing. So in this case, what's changing is both of these, the number of mugs sold and the price per mug. So really, though, what the owner is changing is the increase in price. So we're going to say let x equal the number of 50-cent increases. That's what our variable represents, how many times he increases the price by 50 cents. So we know our profit, we're just going to put P now. our profit is going to be number of mugs sold. So what is the number of mugs sold? Well, we know we start out with 200 mugs being sold. But for each 50-cent increase of the price, so for each X, he's going to sell 10 fewer mugs. So we need to take away from that 10 times X. Because if he has one increase in price, you're going to take away 10 from your sales. So your sales would be 190. If he increases the price twice, so if X is equal to 2, then he's going to sell 20 less mugs. So you would have 180 mugs that you've sold. So that represents the number of mugs sold. We need to multiply that by the price per mug. So our starting cost for a mug is $6. So if there's no increase in price, this would zero out, and 200 times 6, it would make $1,200 right now. But we know that the price is changing. We're going to add to the price 50 cents per increase. So 0.50, or you can just put 0.5, times X. So this represents the price after so many increases, after X number of increases. So if he increases the price once, then X is equal to 1, so that means he's adding 50 cents to $6, so the price per mug is $6.50. If he increases the price twice, then X will equal 2, and 2 times 50 cents is a $1 increase, which means the price per mug is $7. And you would times that by, if it was twice increase, 180 to get your total profit. So this is our equation. So now that we have our equation, we need to find the maximum value. Maximum or minimum value, and in our case, we're finding a maximum. So that's your step 3. And again, in our case, we're finding maximum value. So how do we find that value? Well, we know that the maximum or minimum value for a quadratic, this is going to end up being a quadratic, is always at the vertex. So we need to find the vertex. In order to find the vertex, we need to use that formula, x equals negative b over 2a, but we don't actually know b or a because we're not in standard form. So we need to use FOIL, multiply this out to get in standard form. So we're going to do 200 times 6, which is 1200. And then we need to do 200 times 0.5x, which is 100x, positive. And then negative 10x times 6, which is negative 60x. And then negative 10x times 0.5x, which is half of 10 is 5, so negative 5. And then x times x gives us that x squared, which makes it a quadratic. Now, if you notice, we have some like terms we can combine, so that becomes positive 40x together. And then we do want to rewrite this in standard form. So we're going to rewrite it as p equal to negative 5x squared. Put your quadratic term first, so negative 5x squared, plus your linear term, plus 40x, and then plus 1200. So that is your profit equation in standard form. So now we can identify A and B so that we can find the vertex. So our A value is negative 5, and then our B value is 40. So we're going to do negative B over 2A. So x is equal to negative of 40, our B value, over 2 times negative 5. So we get a negative over negative is a positive, and so that'll be 40 over 10, which is equal to 4. So our x value of the vertex is 4. Now, before we find the maximum value, we can actually answer part A. So it says, how much should the owner charge for each mug in order to maximize the monthly income in their sales? Well, to know that, we need to know how many times he needs to increase the price. That's our x value, so we just found that. So in order to maximize profits, the x value needs to be 4, and the x value represents how many 50-cent increases. So we need 4 50-cent increases in order to maximize the price. So that means we need a total increase of $2 which means our price per mug that we need to do is $8. 6 plus 2, so $8 per mug will maximize your profit. So that's your answer to part A. And then for part B, it says, what is the maximum monthly income the owner can expect to make from the mugs? So if he does charge $8 per mug, how much money is he actually going to make from that? So there's two ways you can find this out. You can go ahead and plug in the 8 into your quadratic here. Or we can actually go back to this form of the equation. These are the same thing. They're equal, just in different forms. But if we use this form, it's easier to plug in. So we already know that this is going to be $8 because when x equals 4, this is 2. 2 plus 6 is 8. And we can just plug it into this part of the equation to figure out how many mugs he's going to sell. So I'll do it both ways. So the first way, 200 minus 10 times 8, because for each increase, not 8, times 4. For each increase, he's going to sell 10 fewer mugs, so he's going to sell 40 less mugs. So he's going to sell 160 mugs for, remember we said that you get $8, it's $8 a piece, so for $8, so 160 mugs at $8 a piece is a total profit of $1,280, and that's going to be your biggest profit. And the other way you can do it is plugging it into our other formula, so P equals negative 5 times 4 squared. Remember, 4 is our X value, not 8. That's the price per mug. And then plus 40 times our X value, 4, and then plus 1,200. So we get negative 5 times 16 plus 160 plus 1,200. This 5 times negative 16 gives us negative 80. And then plus 160 plus 1,200. These together become positive 80, so it's 1,280. So we get the same answer no matter which form of the equation we use. So he will make a maximum profit of $1,280. Again, you're going to have a problem just like this where you have to create the equation like that. So make sure you know how to do this and make sure this is all written down in your notes. And that's it for section 4.1. Your homework will be homework 26, which is just over 4.1, and that's due on Wednesday. So now you need to watch the video over 4.2.